a whole bunch of them, adding up to 43 points there. The first one of is an attempt to see if you can graph indifference curve for individual stated. Let's see what we have here. The first one, general, not picky. Not picky means perfect. So picky means perfect complement. So that's the group number 2. Weird people. This is the sticky perfect substitute. So the utility should look like this. We simply have to identify the alpha and beta based on the number given. Right? The MRS, which is alpha divided by beta, is in fact the trade-off of y for x. So the question says the trade-off is 2 for 3. That's what it says, right? 2 for 3. So this should be 3. This should be 2. Right? That should be 3, 2. This individual likes apple 50% more than orange because he takes 2 apples and exchanges for 3 oranges. So he likes apple more than the orange. That's what this shows. Right? He likes apple 50% more than orange no matter what. So the utility function for him is this one. If you want to graph it, put 2 here, that's 2. Put 2 here. Put 3 there. Graph 1 indifference curve. Let's see, graph this one. That's 1. Or you can go to the other one. 4. That is 6. That is our indifference map. Alright? Most people, not most people, a lot of people have it backward. They put 2x3. Well, those could figure it out. Some people think it's perfect complement. For those who figure out this is perfect substitute, often they miss, not often, some at least, they miss this. They put 2 and 3 backward. You exchange 2 apples for 3 oranges. So it should be the other way around. Right, you should like apple X more than orange. The MRS of apple 3. Sorry, the marginal utility of apple is 3. Marginal utility of orange is actually 2. So like apple 50% more than the orange. Right? Make sense? Okay. Anyway, that's the first one. Second, he likes donut, but he has his limit. He likes it up to 3 units. No information about everything else is given. Everything else sometimes called composite good. Basically means everything else dumped into a variable called y. We call it often composite good. Alright? So sometimes it's composite good, sometimes it's said everything else. If no information about it is given, that's a good. That's not a bad thing. That's a good thing. So this is good. We know this is good. Donut is good up to 3. Thereafter it becomes what? He says, if you give him more than 3, he's not going to touch it. He's going to throw it away. So after 3 it becomes a neutral good. More of it doesn't do anything. You like it up to 3, then you don't care about it thereafter. You like it up to 3, then you don't care about it thereafter. The only thing that makes you happier is more other stuff. So that's the inverse map. If you recall, it's based on this idea. Downward downward means you like it. You like it. Upward means you don't like it. And flat means neutral. So I'm using that one to graph it. You like it up to 3, that's downward sloping towards it. Then you don't care about it, that becomes flat. More of it keep you on the same indifference curve. So you don't care about it. Make sense? If the question would have been, he likes donut up to 3, then he eats it but he gets sick of it. Then it would have been a bad thing. After 3, I would have graphed it. This way, that's a bad thing now. Make sense? So a bit of change, it changed the way the indifference looks like, but the idea is right there. If you're downward sloping towards it, you like it. You give up for it. If you're upward sloping towards it, you dislike it. You want compensation for it. Flat means more of it doesn't do anything. That's neutral. So I'm using that to graph the indifference map. Right? Make sense? Okay. Yeah.
I have a question in part I. You put alpha x plus by.
I put?
Yeah. And
I
apple
put-
is x.
Apple is X.
They said exchange 2 apples for 3 oranges.
Yep.
I don't know why in my mind I said it's alpha is 2.
I don't know what's in your mind.
They said apples, 2 apples, which is.
I know. I actually know what's in your mind.
Yeah.
This is what it says. You exchange 2 for 3. That's what it says.
Okay.
You have it backward.
Makes sense.
If you exchange 2 apples for 3 oranges, it basically means you like apple 50% more than the orange. So the marginal intuitive apple is more than that for orange. You like it more. That's the reason you give up less for more. Make sense? Like I'm saying, I give you. I can't say I give you what, right? That of course. If you're training with your friend, you're giving 2 and he gives you 3, you like whatever you give more than whatever he gives you. Because you give 2, you get 3, right? That's the same thing. So don't think about it. If you think about it, confuse yourself. Write MRS, that's alpha by beta. And the MRS is the exchange of y for x. Based on a statement, see how much you give up, that's changing x. See how much you get, that's changing y. You can figure out the alpha and beta. Make sense? If you graph it, you can see it. If I give you 2 apples, just 2 apples, or 3 oranges, they're the same. The MRS of the slope of that line is 3 over 2, not 2 over 3. It's steeper than 1. Make sense? This is steeper than 1. Steeper than 1 basically means you like this one. The unit of this one is worth more than the unit of that. Make sense? Anyway, but that's sort of very common. That's what I try to say. Most often people have it backward. That is those who actually figure out this is perfect substitute, right? They sort of have it backward because they look at the 2 and they look at the 3 and they think I should put alpha equal to 2, beta equal to 3. If you do it, you get MRS of less than 1. That would imply you like actually y more than x, which is the other way around. Alright? Okay, anyway. Next one is graphing income substitution effect for avocado, which is a given good. It's not, but that's what it is there. The way you graph it is you identify the substitution effect. That is regardless of whether the good is given, normal or not, that's sort of the same thing always. Then you figure out where to put the terminal point, that is based on the nature of the good. So the first thing you do, you graph the initial indifference curve, i.e. the indifference curve on. Point A, don't graph it this way, don't graph it too tight, you're going to get a hard time getting point C from it. Alright, so graph it. Large. That's nice. If you graph it too tight, then when you try to eliminate income effect, get point C, A and C will be so close, very hard to figure it out, right? Okay. So that's the nice graph. Then take the nobody line, shift it back to eliminate the income effect and get point C. Right? That is doing that. Is that parallel? Yes or no? I think it's not. not. See, I'm gonna make it even flatter so I get my cone C nicely done. I'm gonna make it even flatter. It's too steep when you have A and C so close you cannot actually find it. That's A. That's it. So I'm gonna try to get the tendency. Is that parallel or not? It's very hard to see there. It's not parallel, right? No. I don't have a ruler, so I cannot easily do it, but you have a ruler, so you can actually easily find it. Not parallel. Okay, I'm gonna do it nice and round. That's easier to do now. See, you have to have a parallel line. Does it look parallel? That's C. See, the reason you have it, you should have it flattish, because C otherwise will be so close to A, right? Very hard to show it. That's A. That's C. That is what we call substitution effect. So regardless of whether the good is normal, inferior, Giffen, that's the same. So in this case, the price goes up, substitution effect says buy more. If the good is inferior, then the income effect says buy less. That's inferior. If the good is given, then the income effect in absolute terms should be more than substitution effect. So you should end up with buying less. That's a given. So to graph the given, B should be to the left of this one. So if you graph to the left of this one, say B. There. That's good enough. Anything to the left of A will give you a given good. So I graph to the B. That is now income effect. And this is your total effect. If the good was just inferior, I would have graphed D between A and C. Right? If the good was normal, I would have graphed A to the right of C. Alright, but for that type of question, the good is never normal because you have a numerical version of it later. So it's either just inferior or given. Right? That's two. The price either goes up or down, so there are four cases. Make sense? Price going up or down, this is down. The good is inferior or given. Right? Make sense? Okay, anyway. That's the given, this is the way you graph it. If the question was, this is just normal, inferior, not given, then B would have been, say, somewhere there, in between A and C, say there. Then I would have said the income effect push you back, but not so much. So you sit by more, the total effect stays positive. Right? Anyway, but it wasn't in this case, so I graphed this up. Anyway, make sure you learn it, but there are four cases. How can you miss it? So four cases, right? There's given inferior, cross up and down. Four cases. Okay? So, anyway, that is this one. I did it for price going down, do it for price going up, you have all the cases. Okay. Next one. Suppose someone believes in transitivity. Okay, so that is believed in. Then show that crossing indifference map will violate non-satiation. That is a crossing indifference map. I've seen some people graphing it this way sometimes. That is wrong. The indifference curve should not rise up. That is not a good anymore. That becomes a bad. So you graph it downward sloping, right? You should be downward sloping. You Don't graph it upward sloping. That makes it a bad. This is A. That's bundle A. So I graph B and C in a way that the Y is the same, just X is different. So I graph a horizontal line, get Y the same, just make X different. Then I say A and C are the same, they are in U1. They're on the same difference curve, U1. A and B are the same because they're on the same difference curve. Right? And the question says transitivity holds. So the outcome should be B is equal to C. That is transitivity. Which is the follow through, right? And that violates what condition? Non-seriation. Because C is more than B. How can they be the same? C gives you more than B, right? We give you the same Y, more X. How can C not be better than E? That violates non-seriation. Right? Make sense? That's it. That gives you 5 marks. That's lecture 2. Right? Okay? Some of you look so surprised. You have a test on Saturday, right? So this should look very familiar. It's like, well, I know this stuff, right? If it doesn't look so, not good at all, but you still have many hours, not many days. You have many hours. Anyway, you know, years ago, there was a fire down there. There was a fire in a residence. Someone actually died. So, you know what happened? We had a D12 exam on that Saturday. So someone called the fire station, rescued people, because the whole building was occupied by students, right? Someone just split the whole thing and rented to students. Several people in the basement. They started a fire in the basement, and some people were living up there. And you know who called the fire station? A student was doing my exam, studying all the way to 5 o'clock in the morning. That's a bad idea, but I saved lives. If the student wasn't there, the whole building would have been on fire, and then more people would have probably. But he basically called the fire, and they just stopped it. And he called the people in their flat, but one died in fact, right? Anyway, a few years back. Don't study until 5 o'clock in the morning. Make diminishing returns to everything. The more you study, the worse it gets. I never studied the night before any exam. I never. I never did it. It's just my brain was too occupied. I felt like I can't do it, right? But I've seen people studying like to 5 minutes before the exam, right? Just writing their cheat sheet, stuff like that. It's not gonna work. It doesn't normally work, right? You basically miss on easy questions, right? Miss on stuff that you even know, and you cannot get into your brain stuff that you didn't know the night before anyway. That's too hard to do. Anyway, unless you know a question is coming. But if you try to put everything together, it doesn't work. Normally it doesn't work. Anyway, this is a numerical calculation of IESE. See, we're using Cobb-Douglas. Cobb-Douglas gives us a normal good. That's the reason that graph is never normal good. It's never normal good because we already have a graph of it here. That was double dipping, right? So that graph is either normal, inferior, or given. Never normal. Price of Y is how much? 1. The income is 400. Initially, price of X is 2. That gives us the initial bundle, which is how much? 150? 100. That's the initial bundle. When the price of X drops to 1, then this individual buys more A, more X, but the same Y. So we know A to B is What is A to B? That is the total effect of the price change, which is this distance, that is 150. Alright? So, and we know we can isolate for substitution effect by eliminating income effect. That will give us point C. That's what we did on the graph, right? So if we can get point C, that will give us only substitution effect. Right? So substitution effect is xc minus xa. We have to find it. And C to B then becomes income effect. So if you find point C, we can find that as well. So the only thing we have to do numerically is find point C. Right? Make sense? Because we know if we find point C, that's the give us substitution effect, and the total effect is already had. The income effect can be found from it. Alright? That make sense? Okay. See, I have a graph there. So you may say, well, let's put the numbers in it. I gave you the numbers, so you can put, this should be 200. That's 150. That's 100, that's 100, that is 300. So I give you A and B. So you may say, well, let's graph the indifference curve as before here. Shift the body down, get the C, and just find it. If you do it graphically first, when you buy, you don't know where you end. You may end up with less than 200 more, and the numbers may not match. Then you have to regraph it. Make sense? So you're probably better off solving it than graphing it, because otherwise you may have to regraph it. That 200 is a problem. If C is more than 200, and you end up graphing showing less, then the graph is wrong. Make sense? So I'm going to find it, then graph it. Right? Okay. To find point C, we need to satisfy two conditions. What was number one? Utility of A is utility of C. So we're going to plug A in the utility function. That is the utility of C that we have to find. Make sense? So I'm going to get rid of 100. 10, sorry, we don't need it. I need this number though. How much is that? How much is that? Why would anyone take the microphone? What is point? What is the numerical part of the utility? I don't want to say utility because that's 10 is eliminated. How much did you get? 1? How much?
1071.
107? That doesn't. Are you sure?
No, it is 1071.
1071?
1.54.
That doesn't look right. Are you using 10? Eliminate 10. This 153 for 100, 140. These both less than 100. It can't be so hard. It can't have a CR. It's a small number. How much do you get? 135? Point? 5. That's more like, think about it. This is like, this is a small number. This is far less than 10. This is a small number. You multiply them, you can't get such a big number, right? It's a small number. But it's 135.5. That's the one I remember. That's probably right. Okay. Is it 135.5 or 4? I don't know. I remember 4 somewhere. So this is 4? Okay, that's more like it. That's 1. 2.
No, 0.5, so it's 0.5.
Don't be so mad. I can't hear. Okay, that's fine. 2. You have a tangency there. 2. No. dotted line, not the old one, the new one. That's the tendency. So the only really thing we need here is MRS. What's the MRS of that function? Alpha, beta, y, x. Right? So now we have to solve it. I'm going to get you this for yc is equal to xc divided by 3. Am I right? Yes. So I'm going to take this one, put it there, and get x. How much is xc? Since the good is normal, you should get it between 150 and 300. How much is 135.54 divided by 1 over 3 to the power 1/4? Take this one, divide by this, that's xc. It will be between A and B, so it should be between 150 and 300. What do you get? What do you get there? I know. How much? 178. That looks right. 178? That looks right. Within rounding. So that should be 178.4 minus 150. That is 28.4. This should be, this is C, where do I write C? That should be 300 minus 178.4, that should be 121.6. Within rounding, within rounding. Make sense? Okay, that is it. In this case, the income effect is far more than substitution effect. Most of the effect is income effect. The reason why the individual consumes so more because he has so much money. Mostly because he has more money. Right? Yep.
During the exam, can we round to like 2 decimals or something?
2 decimal is sort of safe. We don't care about. The question doesn't say anything. Rounding is not an issue, right? But most often when you round with 2 digits for everything is fine. Right? Most often even 1 digit is fine, but 2 is safe for everything. So the question doesn't say 1 is fine, but 2 is better. Okay, so let's graph it. C is below this one. Before I will graph it differently. If you graph it before, then you don't know where it ends, right? So I know C is before this one. So I will graph it to make sure that's the case. So I'm going to graph the indifference curve now. Flat enough to make it like that. That's the indifference curve. Now I'm going to take this one back. Get the tendency there. That'll be fine, right? So I'm going to get the tendency where I want it. If you make it too curvy, you're not going to get the C far off from A, so it will be very hard to short. Is this parallel? Almost. Is this parallel? No. Is it? That looks parallel, right? That is C. That is 178.4. This is substitution effect, and this is the income effect. Well done. Right? Anyway, I've seen people graphing the indifference curve so for some reason, a lot of people do it. They graph it like this. You're not going to get anything from it, right? You're not going to get point C. And the indifference curve is actually flat often. It's not so tight, right? And that's a common mistake. You graph it too tight, and you're not gonna get point C fall off from A. You're not gonna get anything from it. Graph it the way I did, which is flattish. Then you're gonna get nice difference between A and C. Right? Make sense? This question, everyone knows is coming. That's the seventh one we solved, right? We did 6 of them in class. Yes, we did 6. That's 7. 7 on the test. People miss the numbers, they miss the graph, they miss both, which is very unfortunate, right? Because the crux of the demand theory, you should know how to work with it, right? So practice it. It's coming. I can actually be not so nice, give you CS there. Even for CS, nothing really will change. The process will remain the same. The difficulty with CS is then you don't have a straight line. PCC, the PCC will be downsloping. So the graph looks more difficult, but the process is the same. I actually did that one on the recorded lecture. So you can do it for any utility function, but I normally test was give you cup Douglas. That's just to simplify. Alright, so there's no reason to miss it. Alright? Okay, next one. A consumer has $50. She spent it on 2 goods, X and Y. The prices are 1. So this is the information given. What is this? Why this is so light? What kind of pen is this? It's a pen that does not write. So why do you even have it? Anyone? What does that do? Why do you need it? Ask in Microsoft. That's one. So for the timing, up to this point, that's the information, right? Up to that point, if you ignore everything thereafter, that's the bottom line. So if you ignore any information given thereafter, the bottom line is straight, crossing the 2 ends at 50. But the store offers a special. That's what it says. The store offers a special. If you buy 5 units, I'll give you 2 for free. Alright? So if you buy 5 units, if you do so, you end up with how much money? 45. Then you get 2 for free. That'll take you all the way to how much? 7. You still have how much money? How much money you have? 45 bucks. But thereafter, the price of X becomes how much? 25% lower. What's the price now? 75 cents. So if you spend all the money on X, that's the maximum you can buy. If you spend everything on X, that's basically regular. That's 2 for free. That's the amount you can buy at 75 cents, I mean 25% discount. How much is this thing? How much is the real bottom line, which has technically 2 kinks, 1 due to free offer, 1 due to discount? What's the maximum you can buy? 67. So the real bottom line actually hits there as 67. That's the real bottom line. I should cross this out. That's the real bottom line. I graphed that part because I want to get a nice slope for the first part. But that's not part of the bottom line. The real bottom line is the one that shows up there now. Alright? Now this slope is 1 because the price there was 1. This slope is how much? 0 because it's free. The price is 0. This slope is 12.75. We're going to get 25% discount. Push the price down to 75 cents. Make sense? So we get 2 kinks. Because free offer push the line flat, discount push the line to 7%. Right? Make sense? Okay. So make sure if you do it the way I did it, cross this out. This is just demonstration of what the line would be if the price was staying at 1. I graphed it to get the slope of this part nice. That's the only reason I graphed it. To get the slope of that part, correct. So you cross it out at the end. If you don't, that means you can somehow access that bottom line, which you can. Right? So the real bottom line is, as I said, that's the real bottom line. That's the bottom line, the rest are just for demonstration. But the way I graphed is probably preferred, because you get a nice slope. If you don't graph it the way I just put lines there, you're not going to get a slope. Yeah?
So in the exam, do we erase this part of the line? Just draw the...
Do it the way I graphed it, cross that out, because otherwise you're not going to get a slope.
Okay.
You're going to get slope that does not comply with the number, right? This is better. Graph the line without any discount, then cut it at the discount, then apply the discount. Yep.
Can we grade the exam with pencil or open pen?
If you write with pencil, you cannot ask for regrade. But that's the rule, right? But you can write with pencil, you cannot ask for regrade at the end. If I were you writing with pencil, I would basically got the last poem, put it in pen. The calculation is nothing. For the last numbers you get, write in pen. That will basically fix the issue of no regrade. Right? Okay. Okay. And don't scribble. Don't say, go to the page 5, that's the question, then go back to page 10. I see people doing this way. You know, once upon a time, someone did it that way. A long time ago. So I had a student who came to the office. That students were crying, right? And I said, what is going on? He said, that's the highest mark I ever got in any course in economics. This is what the TA wrote for me. You know what the TA wrote for? An insult, like F up. How can I read your paper? I don't know, the TA probably was drunk, but the TA wrote an insult on the paper because the student did not write nicely, and the student did not write nicely, right? Like scribbling on the page. But the TA got so mad, right, that he just wrote stuff, right? And we brought the TA, I said, what is going on? Why did you write this one? He said, I didn't write it. Who wrote it? He said, I took it to the dormitory and someone else wrote it. The TA was not truthful. And that is the reason we don't allow TAs to take the paper out of the building anymore, because someone took it and the claim was someone in the dormitory wrote an insult on a paper, right? The TA wasn't truthful, she wrote it herself, right? Because we matched the handwriting. But the TA was so mad because someone wrote scribbles, right? It's very hard to write, to read what you wrote. You just scribble around, right? Write it nicely, right? Anyway. Next one, Jack is very picky. This was actually Vicky is very picky, but Vicky got very upset. So I changed it to Jack. And that's not the Jack we know, that's some other Jack. I don't want to get anyone upset, it's just a name. Jack is very picky. Very picky means perfect compliment. So that's known already, that's perfect compliment, so utility should look like this. You just have to find alpha and beta and then solve it. And I think a lot of people cannot find alpha and beta. If you want to find alpha and beta, there's an easy way of doing it. Write y here, write x here. Put the numbers given, 4 and 2. Try to find the slope that gives you those combinations. What should be the slope there? What should be the slope? No, look at the relation I wrote there. That's x4, y is 2. What's the slope of that line? 1 over 2. That's the perfect combination line. You can write it this way, or you can write it this way. That's the same line. Make sense? Or you can write it this way. They're all the same. So either one you use, I will give you exactly the same demand. Right? The utility then looks like this. That is one way of writing it. Or you can use a second one to write it. They're all the same lines. So all these utilities technically are equivalent. You can write 1, 2, 3, they're all the same lines, right? Make sense? 1 is fine, 2 is fine, 3 is fine, they're all the same. So you use either of them, you get exactly the same. Or you can use, I don't know, 8, 4, it's the same line. Any combination is the same, right? So I wrote the utility. If you would have written any one of those, it would have been fine. Then I tried to find a demand. If you try to find a demand, that is your perfect combination line. You're going to use it. And then you can use the bottom line to solve for it. What is this? Go on. So take this one, plug it there, and solve it. So what should we demand for x? It should be I px plus half of py. And then I can take this one, plug it there, and get demand for y. That should be I 2px plus py. I found demand for x, demand for y by using perfect complement relation as well as the bottom line and solving. Alright? Make sense? Okay. That's this one. Then I want to find angle curve. The angle curve will be just take the demand, isolate for I. I take this one, isolate for I. That gives you angle curve for x. This is the angle curve for x. Then take this one, isolate for I. That is angle curve for y. Make sense? As long as you identify the perfect complement relation, the rest are just using those two equations. Okay? Okay. Now, when this question was on a test, people were asking, you didn't give us prices, how do we find demands? Demand only uses utility function, that's it. I give you the price and income, that become a point on the demand. That becomes what we call optimal allocation of funds, which is one point on the demand. So the only thing you need to find the demand is utility function, which is given there. Make sense? Okay. Okay, if it makes sense, we can move on. Last short question. If I do this one, I've done 43% of the test. Yes. This is market demand. We did several of them. That's similar. We have two groups in the city, one called J. That's their inverse demand. And that's the actual demand. What's the reservation price for group J? What's the reservation price for group J? How much? 6. Put the quantity equal to 0, get the reservation price. So I put 0 here, I get 6. That's the reservation price for J. K, that's the inverse demand. And let's see actual demand. The reservation price is how much? 9. Right? Okay? Make sense? Okay. So the market demand becomes what? 50, there are 50 in each one. 50 QJ plus QK, which is 50, the sum of these two. If the price is low enough for everyone to be in the market. That's the demand when the price is low enough. I just sum these two up, or sum these two up to get this one. When the price is more than 6 all the way to 9, this guy will leave the market. The other one will stay, they will have all the demand. So that is the demand in that case. We have the kink market demand. Finish. That's the kink market demand. Right? Make sense? Okay. Okay. Let's graph it. The highest price in this market is how much? 9. What's the highest quantity? What's the highest quantity in this market? That's when the price is 0. How much do you get? 175. You should use the first line. That is when the price can be less, it can be 0. The kink is when the price is 6. That's when the two lines intersect. So if you use either of these two, you should get the same number. If you use the second one, that's the easier one. That's 25. Verify. Do you get 25 from the first one? That's where the two lines intersect. So in either one you put 6, you should get the same number. You can see the second one give you 25. What about the first one? Does it give you 25? 25, right? We'll find that. So make sure to verify it, otherwise you may get it wrong. That is a market demand kinked at 6. Okay? So we did all the way up to here. The price is 3 going to 10. The price is 3. What's the demand? You can put 3 in the first one. That's when the price is less than 6. 3 is there. How much do you get? What do you get when the price is 3? 100? 100, right? 100. That's a surplus. If the price goes to 10, what will be the surplus? Anyone? The price is 3, that's the surplus. If the price goes to 10, what will be the surplus? Nothing. Everyone leaves the market. Nothing will be bought, no surplus. So the change in the market surplus when the price goes from 3 to 9 is that area. That area. That's all will be lost. And the way it is here is not very hard to find it because you basically have 3 areas. So you can easily calculate those 3 because the way I had it, when the price rises, it goes above everything. So everyone leaves the market. So you know the terminal is 0. So you simply have to calculate 1, 2, 3. But as we had in the class, if you do it this way and you miss the numbers, you get nothing. So I prefer you using individual surplus change and stacking it up. Alright? But here, 1, 2, and 3 added up, that's very simple. I'm going to do it both ways. But I prefer the individual setup, because if you make an error there, you get partial points. If you make an error here, you get nothing. Okay, so let's see. I'm going to do it individually. I'm going to start with J, see what happened to them. I'm going to graph this one and see what happened to them when the price goes from 3 to 10. That is 6, 3. When the price is 3, what's the demand for each individual in J? 1. is 1, right? This is 1. So the surplus when the price is 3 is this. That is 3 multiplied by 1 divided by 2. That's when the price is 3. When it goes to 10, all will be lost. The whole thing is gone. So the change in the consumer surplus for J, each individual is how much? 1.5 bucks, they're going to lose it. So technically I calculated this area. That's 1.5. But there are how many people in J? In J group? There are 50 people there. All together lose 75 bucks. Make sense? So all together we lose 75 bucks. That's one group. Then we're going to go to the other group, which is K. We'll do the same thing there. That is K. That's the demand. That's the inverse demand. When the price is 3, let's graph K first. 9, 1.5. When the price is 3, what's the demand there? Help me out. When the price is 3, what's the demand? 1. So that surplus all will be lost when the price goes to 10. The change in the consumer surplus for group K is, that is lost, that is 6 multiplied by 1 divided by 2, which is minus 3. But there are 50 people there, right? All together we'll lose how much? 150. The change in the consumer surplus for the market is the sum of these two, which is minus 225. So if you do it individually, you're going to get 225. Right? Make sense? Now, if you miss something there in the calculation, you get partial points. If you do it on the graph, you should get the same thing. But if you miss it, you will get nothing because you're doing geometry and you cannot even do geometry. That's the problem, right? Anyway, let's do the graph, see if we get the same thing. What's area number 1? What is area number 1? That is 3 multiplied by 25 divided by 2. That's number 1. What is area number 2? That's 3 multiplied by 25. Right? What's area number 3? That's 3 multiplied by 75 divided by 2. Sum them up. What do you get?
225.
225. So it's the same. You get the same loss. Here is very simple because the price exceeded 9. So the whole area is easy to calculate. But if it was lower, then it will be harder to calculate. There are more areas to worry about, right? Anyway, either way works. I will prefer the way I did it individually, but if you do it this way and get it right, you get the marks. This second part has 4 points. So be careful. If you try to do it using the graph, you may lose all 4 points. Right? Okay, that is this one. Next one is lecture number 1, which is finding demand and supply and doing demand and supply analysis for given numbers. Here we have the price at 2 in equilibrium, the quantity at 300,000 in equilibrium. The elasticity of demand is minus 1. That for the supply is 2. If you recall from lecture number 1, you can do it 2 ways. Get the demand or get the inverse demand. Alright? Make sense? You can do it 2 ways. Get the demand directly or get the inverse demand. Which one is better? It depends on what the shock is. If the shock is tax or subsidy, you should probably calculate inverse demand. Yep.
So for the question above, I just have a question because.
Which
the-
question?
The question above.
Oh, okay.
So.
If you don't stop me, I keep going. Just stop me within the question.
Okay.
Yeah.
So you got negative 200.
I see.
Does the
When you-
negative number matter or?
No. Because we know it's a loss. See here, since I went from 3 to 10, the loss didn't apply. But there, I just calculate the area. So I know it's a loss. You can assign you just write a loss, that's fine. But when you do it the way I did it, the number, the direction of the change in the step is assigned to the number. Make sense? But it doesn't matter really. That's a loss. We know the step will go down by that number, so it's fine. Okay, here you can do two ways. You can calculate inverse demand or the actual demand. Yes.
I have a question about these. Yeah.
Okay.
So for the first triangle on my left,
Hmm.
there's 3 on the x-axis.
Which one?
So
Area number 1?
the p less than 6, the triangle for the p less than 6. There's a 3 on the x-axis.
P less than 6? P less than 6 is relevant.
No, I mean the triangle that has 6 and 3 on the x-axis.
No, we have 3 areas. 1 and 3. They're all triangles. 2 is not triangle. So which one you're talking? We have 1 and 3 only. We don't have anything else. We don't have anything lower than 3. The surplus remains. It's not lost. So we didn't care about it at all. Are you talking about this one?
No. I'm talking about the one
The J
below
triangle.
on the left.
G.
One for J.
Oh, there. Oh, I see down there.
Yeah.
Okay.
Where did we get the 3 on the x-axis?
We get 3.
Yeah.
The price is 3. I calculate the surplus for it.
No. I mean the x-axis.
Oh, this one?
Y-axis. Yeah.
It's 2. That's I'm
Okay.
probably miswrote. I see. It didn't impact anything, but it should be 2, right? It did not impact anything.
I just wanted to check.
Yeah, it's okay. You got me. Okay. It's fine. It didn't impact anything. If it was impacted, we don't notice it. But I just draw that line and I do it wrong. Right? Okay. Next one. We can do it 2 ways. We can actually get the demand or the inverse demand. Is the same. Now it's easier to do the inverse demand when the shock is tax or subsidy, because to apply the shock we need the inverse. If you find the demand, then you have to flip it. Why do you want to do it? That's a waste of time. Right? But anything else, any other shock, we don't really need the inverse, we need the actual demand and supply. So that is this question. If you look at the shock, not the tax or subsidy, demand has shifted. We need the actual demand and the actual supply. So when I solve it, I write the actual demand and I write the actual supply and I try to find A, B, C, D. Right? So for anything but tax or subsidy, this is preferred, this is faster. If you get the inverse, then you have to flip it, get the actual. Waste of time. Okay. Now I say elasticity of demand is slope of demand function, equilibrium. I have the elasticity of demand that is -1. I have the slope, I have the price and the quantity. And I need the slope of demand. Based on the notation I use, what's the slope of demand? B?
Minus B.
Minus B. Because the way we wrote it, there is a minus there. Then that will give us the B, which is 150,000. Right? Then I can say that's our demand. I don't have A yet. I found the slope. I know the price is 2. I know the quantity is 300,000. So how much should be A? That should be 600,000. Right? 300, 300, 600. Make sense? So I found the demand function. That's the demand function. Make sense? Okay, we'll do the same thing for the supply. So I can erase this one. Now we don't need it. We'll do the same thing for the supply. That's the velocity of supply, which I know it is equal to 2. That should be equal to the slope of supply, which is D, and price quantity, which is 300,000. So what would be D? What would be D? That sounds like 300,000, right? Then that's the supply. This is 300,000. This is 2. So how much should we see? Minus 300,000. Right? So I'm going to get the supply, quantify this one. Just a note, the demand can never have negative slope, negative intercept, sorry. That's impossible. But the supply often have negative intercept. It basically means you're not going to produce when the price is 0, which is the case. It basically means you need a price more than 0 to produce, which is often the case. So often the demand has, often the supply have negative intercept. Don't be surprised. Don't be surprised at this one. But demand can never have negative intercept. Impossible. So now we have to apply the shock. That's our new demand, which is a multiple of the old one. What's the multiple based on the information given? Gone up by 10%. So what should I multiply the old one to get the new one? 1.1. That's 1.1. That is our old demand. And that will give us our new demand. Right? The supply is the same, hasn't moved, so I can just write it. If you put this to equal, you get your new price. How much is it? What's the new price? Let me graph it. You can figure out where the supply would be. That's the demand. That's the supply. The demand is shifting out. So the price should be higher and the quantity should be higher too. What do you got there? What would be the new price? I know it's higher than 2. 2 points?
0.6.
0.6. Now give me the new quantity here as well. Just take this one, plug it there. It would be higher than 300,000. What do you get? Do I remember 318? 318? Rounded? Yes? You rounded to 318? What else do I remember it? Yes? Yes. Okay. Now I have to graph it. Should I graph it this way? I give you 3 options. That's 1. Should I graph it this way? That's 2, or this way. Which one you prefer? 1, 2, or 3? Which one you think is appropriate in new demand? Is it 1, or is it 2, or is it 3? It can't be 1, because that's not a parallel shift. The slope will change by 10%. Not a parallel shift, it can't be 1. So you have 2 or 3. Is it 2? Because the slope here goes up, but that's for the demand. We're graphing the inverse. The inverse demand slope goes down. That's a correct graph. That's the quantity. That is the noon price. Question for you economists. Why the price doesn't change much? See, it's a 10% demand shock, but the price only goes up by 6 cents. Why? Because the demand is elastic. Elastic demand means the quantity reacts more than the price. You can see there, right? The quantity goes up by 18,000. That's a lot of change, right? The price goes up by just 6 cents. Percentage-wise, the price does not react much because the demand is, the supply is elastic. The more elastic supply is, the less price reacts. Graphically speaking, you're basically saying the supply is sort of horizontal. My graph doesn't show it, but the graph is more horizontal, the more elastic, the more the quantity reacts than the price. Make sense? So when I look at the numbers, I know that the supply is very elastic. You'll end up with not much change in the price, big change in the quantity when demand shifts. Okay? Okay. We'll take a break. We'll do the rest after. Let's take a break. Short break.